Picture this. You're looking at a sunflower. You noticed those seeds aren't randomly arranged, they're following a precise mathematical pattern. The same pattern shows up in pinecones, in the way leaves arrange themselves around a stem, and even in the spiral arms of galaxies. Maybe if there was a secret code embedded in everything of the universe, a language that could decode the mysteries of reality itself. And what if that language was math? Most of us think of math as a set of rules we learned in school, numbers, formulas, equations. But could it be more than just a tool for solving everyday problems? To understand that math isn't just a human invention, but rather the underlying language of the universe, a way to reveal patterns, predict outcomes, and perhaps one day help us understand our place in the cosmos. Let's start by taking a look around us, in nature. Have you ever noticed how certain shapes and patterns repeat over and over again in the natural world? Think of a sunflower's spiral or the branching veins of a leaf. These aren't random, they're following specific mathematical rules. One of the most fascinating examples is the Fibonacci sequence, a series of numbers where each is the sum of the two before it. This simple pattern shows up everywhere, in the petals of flowers, the spiral of seashells, and even the way pine cones are arranged. It's like nature has a blueprint, and that blueprint is math. Then there are fractals, those complex repeating patterns that look the same, no matter how close you zoom in. We can see fractals in the structure of snowflakes, the rugged outline of a mountain range, and even the branching patterns of rivers and trees. Fractals help scientists describe the seemingly chaotic yet structured way that natural forms develop. These patterns suggest that nature might actually be built on mathematical principles, and it's math that helps us recognize and describe them. Now let's add a layer of complexity with something called chaos theory. Chaos theory studies systems that appear random, but underneath the surface, they follow precise rules. Ever heard of the butterfly effect? It's the idea that a butterfly flapping its wings could eventually trigger a tornado on the other side of the planet. While this may sound far-fetched, it illustrates how small changes in a chaotic system can lead to massive effects. Chaotic systems, like weather patterns or even the stock market, might seem completely unpredictable, but with the right mathematical models, scientists have found hidden orders within this chaos. Chaos theory helps us understand that there's a kind of organized unpredictability at work. It's as if the universe has woven order and randomness together in a delicate dance, and math helps us see both sides. But here's where it gets even more fascinating. If math can describe so much about our world, could it be a universal language? Imagine if we encountered intelligent life beyond Earth. How would we communicate? We could try words or symbols, but would they understand them? Many scientists believe that math might be the best way to bridge that gap. Why? Because math isn't bound to any culture, species, or language. It's a set of rules based on logic and patterns, which could make it universal. For example, we might start with something fundamental, like prime numbers. Numbers that can only be divided by one and themselves. Since prime numbers follow a specific pattern, they could serve as a kind of introduction to extraterrestrial communication. Scientists have even sent signals based on mathematical principles into space in the hopes that, if someone or something out there picks them up, they'll recognize it as a message. Beyond communication, math is essential in helping us unlock the mysteries of physics and the universe itself. Math underpins our understanding of gravity, electromagnetism, and even time. Take Einstein's theory of relativity. It's a mathematical description of how objects in space and time interact. On the other hand, when physicists peek into the quantum mechanics, they find equations. Perfect, precise equations that describe how everything, from the smallest electron to the largest supernova, behaves. Even when things look random to us, there's often a hidden mathematical order lurking beneath the surface. In recent years, physicists have proposed theories like string theory, the idea that all particles are tiny vibrating strings of energy, each with its own frequency, and it goes deeper. The latest studies in theoretical physics suggest that the fundamental structure of space and time might be mathematical at its core. Some scientists now believe that mathematics isn't just a tool we use to describe the universe. It might be what the universe is actually made of. But perhaps the most exciting frontier is in artificial intelligence. The latest breakthroughs in AI have revealed something fascinating. When we create systems that can understand advanced mathematics, they start to recognize patterns that we humans never noticed. It's as if they're picking up on a universal mathematical frequency that's been humming in the background all along. So is math the ultimate language of the universe? Could it be the key that unlocks every mystery, from the patterns in a sunflower to the behavior of galaxies? We may not have all the answers yet, but one thing is certain. Math gives us a way to understand, predict, and connect with the world in ways that feel almost magical. Next time you look at a shell, a snowflake, or even a starry sky, consider this. You might be seeing a little glimpse of the universe's hidden code. If you enjoyed this journey into the mathematics of reality, let us know in the comments if you've ever noticed these patterns in nature, or if you think math could truly hold the secrets of the universe. Don't forget to like, subscribe, and join us next time as we explore more mysteries of science, nature, and beyond.